2, here's where we really got to read the question, right? And I think it's a very important thing that you actually read the question first. So it says, in the diagram below, AB and BE are tangents to the circle. Yay! Okay, so the moment you see you've got tangents, you know you can start using, somewhere there will be theorems such as the tan chord theorem, right? The tan chord theorem. Somewhere in play, the tan chord theorem will come into place. Okay, so I've got that. AB and BE are tangents to the circle. Now, AF equals FE. AF equals FE. AF, that side there, is the same as that side there. And let me get some color in. Let me get my highlighter. I've got a turquoise highlighter. I'm going to put it there. That length there is the same as that length over there. Now that tells you something. When you have two lengths the same, that's an isosceles triangle. Now, and EF is parallel to DB. That's EF parallel to DB. Yes, parallel lines, parallel lines. Okay, already I've got things coming in here. I've got isosceles triangles. I've got tangents. I know the tan chord theorem is going to come in somewhere. I've also got EF parallel to DB, and then I've got something else. I've got parallel lines. Now the reason I'm writing all of these things down is so that we can realize that I'm going to use a little bit of each of this when I solve the questions, right? And then they tell us AD, AC, EB, and DB are straight lines. Okay, they've drawn it for you and they're telling you to you as well. And then they told you B3, that little angle over there, angle B3, they're calling it X. They're calling it X, right? They're calling B3 X. Now, this particular question says, write down with reasons another 5 angles equal to X. Now, seeing as though I've just looked at the question and I found 5 angles, all of those angles require you to understand a little bit about the tan chord theorem, parallel lines, and also isosceles triangles. So what I'm going to do is I'm going to give you a 3 to 4 minute crash course on the tan chord theorem, on parallel lines, and also on isosceles triangles before we answer the question itself. Okay, so let's look at that crash course. Okay, let me get started. Let's see how we start on this. Let's start with parallel lines, right? Now parallel lines are very important because they are a condition for using fun angles. They are a condition for using fun angles. Now, when do fun angles come into place? Into play, right? It happens when I've got two parallel lines as such, right? And then I've got a line that cuts it. So I'm going to indicate that those lines are parallel. Oops. Right? Those are parallel lines. You can either use single arrows or double arrows. It doesn't matter as long as the convention holds, right? So those two lines are parallel. And now when I have a line that cuts it, such as this line over here, that line is called a transversal. It's called what? A transversal. Right. A line that cuts two parallel lines is called a transversal. Now, if I've got parallel lines, I'm going to get angles that are either equal or they add up, or they are supplementary, or they add up to 180 degrees. So look very, very carefully over here. I'm going to say, well, I'm going to call this angle B. Let's label the lines as AB and CD. Sorry, AB and CD. And then I'm going to say, well, okay, I'm going to make this, I'm going to name some angles over there. Blue, red, yellow, green. What do I choose? Okay, let's leave it black. I'm going to make it E, little e, and F, and G. Oh, let's make G over there. G, H, little I, J, K, and L. Now note that E, F, G, H, I, J, K, L are all angles. Now, the moment you have parallel lines, look for the transversal. The transversal will tell you whether I'm looking for fun. If I'm looking for the F, when I have the F, I've got corresponding angles. So that's going to be that all the below the f's, right? Or this angle plus this angle must add up to 180. Or if I look for an n or a z, then these are alternate angles. Now, if I look at a pair of corresponding angles, I would say, let me find an f. Now, do you see there's an f? If I take away the entire, if I hide, if I were to hide everything on that side, and I find this side over here, that looks like an f, right? Then I can find angles that are equal. Firstly, I'm going to say angle H is equal to, angle H is equal to angle L. And I have to give a reason. It's very important. I'm going to say it's corresponding angles, and I need to say why they correspond because I've got a set of parallel lines. So AB is parallel to CD, right? AB parallel to CD. Then I've got another set of corresponding angles. I've got the upside down F that goes this way. If I were to use my highlighter, I'd say it is an F that's going like that and so, and an F that goes so. Do you see that? That's an upside down F. So now I'm looking for this angle, little f and little j. Okay, so let me type that solution down. Little f is equal to little j. And I'm going to have the exact same reason. Corresponding angles with AB parallel to CD. Let's get another set of corresponding angles. Let's take that same f but go in the opposite direction now. I'm going to go with an upside down f. Oops. That looks like that. And I'm interested in this angle here and that angle there below the parallel lines, right? So little e is equal to little I. Little e is equal to little I. Corresponding angles AB parallel to CD. And let's take the same f, but let's not go upside down, but rather back to front, but not upside down, just only back to front. And now I'm interested in little g, which is equivalent to little k. Little g is equal to little k. Okay, little g is equal to little k. Right, so there I've got a set of corresponding angles. F corresponds to J, H corresponds to L, G corresponds to K, and E corresponds to I. Are there any other corresponding angles? No, because I've covered the entire set of the triangle. Okay, so that covers the F. Now we want to start looking at U, right? And I'm going to start looking at the sets of co-interior angles in a moment. Okay, so let's continue with this now. Now I'm interested in the U, right? So again, those are my two parallel lines, and then the angles that lie between the parallel lines. The angles that lie between the parallel lines, right? Those are called co-interior angles. So, well, let's see if we can find a U. There we go. There we go. There's a U. Do you see the U? Yeah, we see the U. Great. So there's my U. And the U is enclosed, right? The two side arms of the U are your parallel lines. So what do we know about angles that lie on parallel lines? Well, in the case of a U, H plus J will add up to 180 degrees. So let's just say that. Let's say angle H, okay, let's be a little bit neater. Angle H plus angle J must equal to 180 degrees. And then I've got a set of reasons for that. My reasons are they are called co-interior angles because co-interior angles are supplementary. And I need to say why, because AB is parallel to CD. Okay, now that's not the only set. There's another set. There, I've got the parallel lines. Okay, do you see that? And I've got a U with the two side arms of the U being the parallel lines and this being the transversal. So G plus I also adds up to 180 degrees. Little g plus little I is also 180 degrees. And I use the exact same reason. Okay, and then finally, the last thing we're interested in is talking about something called alternate angles. Okay, so the alternate angles is where we use the parallel lines, but we start looking for a Z or an N, but they can be stretched. They can be stretched a little bit, right? So let's see if I can find a Z. Well, there's a first Z. Do you see that Z over there? That's one Z. And so the angles that are uh, alternate angles in this case are little g and little j. Okay. Oops. Little g and little j. Angle little g is equal to angle little j. And the reason for that again is these are called alternate angles. And the reasons we give is AB parallel to CD. Are there other sets of alternate angles? Well, yes, there's another Z. There we go. And I'm now interested in H and I. Well, little h is equal to little I. That's an H, right? Not an N. And the exact same reason we use, right? So remember your reason is as the reason above here. Okay. Are there other sets? Let's see. Little h equals little I. That's my Z. That's another Z. Yeah, and there we go. Now, I'm going to touch on one other thing. The last thing I want to mention in our set of fun angles, which isn't necessarily a property of fun angles, but rather a property that holds with any two lines. So if I have a line, for example, my apologies for that, we had a call coming into studio a moment ago. But nevertheless, let's get on with what I was speaking about before the call. Is between any two lines, there's something called vertically opposite angles, right? So this angle A, that's B, that is C, that is D. Whenever you make a cross between two lines, then you're going to get the lines, the angles that are opposite them, those are vertically opposite angles. So in this case, angle A is equal to angle C, right? And your reason is vertically opposite angles. Well, I think we really need to improve on that, that graffiti over there. Vertically opposite angles. Okay, right, so here you can see that clearly F is equal to G, and little e is equal to little h, and little j is equal to little k, and little I is equal to little l. And so that gives you a wrap of parallel lines.